Okay, moving on to the rocket question. We're kind of in an order here to deal with some things that come up. Always draw a free body diagram first. So for a rocket question, it clearly says there's an upward force of 15, so a dot to represent the rocket. I'm going to call it FA for F applied. I don't really care what letter you put with it, but some sort of letter F equals 15 newtons up. The most common mistake with the rocket question, and part of why we're doing it, is often people just leave it like that. Say, okay, we got 15 newtons acting on a particular mass, so F equals ma. What we have to remember is that there's still gravity. It doesn't say that the rocket's in deep, deep outer space. It's a toy rocket, so some kid's launching it in his backyard. We've got to include gravity, which we'll get the hang of is always m times g. When we're setting up our F net equals ma, it's easiest to always make the bigger force, if you know which one's bigger, or the direction of acceleration positive. So in this case, eyeballing it, I can tell that the 15 is bigger, or if I don't, it's a rocket. It's going to be accelerating upward. So I'm going to call the upward the positive force, and that means gravity ends up being our negative force. F net is equal to ma, so it's really the difference when we take gravity off of the F applied, whatever's left over there, that's what makes it accelerate. At this point, the way this particular question is typed up, I've asked for the acceleration. We now know, here we'll do one more line, we now know everything but the a value. So if we plug in our values, 15, take away the mass I made up was 0.5, multiply that by 9.8, you're going to get a number around 5, and that's equal to 0.5 times a. So we've got this number 15, take away a number around 5, that's going to be pretty close to 10. And we've got to divide that by 0.5 to clear to get a all by itself. So double check my algebra, but within rounding, I'm getting an acceleration of 20.2 meters per second squared.